So on this question, first of all, let's have a look at what we've got in the question. In year 11 of a certain school, 55% are boys. If I was answering this question, I'd do, first of all, probability of a boy, 0.55. And then I would try, if I was doing something exam particularly, just double check, have I written that down correctly? 55% boys, yeah. So the first thing I would do is just get rid of all the writing. Of the boys, 80% stay on to the sixth form. So I've got some probability which is 80%, 0.8. Can anybody tell me what that 0.8 is, how I could write that down in notation? Of the boys, 80% stay on into the sixth form. How can I write that down in some sort of notation? Let's use B for boys, G for girls, and the number 6 for staying on in the sixth form. Yep.
Is it probability of being given 6?
Probability of...
given 6 given B.
Yeah, probability, given they're a boy, so that's got to, the boy bit's got to come after the man. Given they're a boy, the probability they stay on in the sixth form is 0.8. So we've got that bit there. And then 75% of the girls do. Can anybody tell me what I can write down for that 75% then? What that will be in notation over here, where it says 75% of the girls do stay on in the sixth form. Sunny?
6 given G.
Yeah, that's right, okay. So that's the information I've got in the question. In part A, what's it asking for in part A? The probability a random selected pupil from year 11 is a girl who stays on in the sixth form. So can anybody tell me what I will write down in that bracket if I'm going into notation? Part A. The probability a randomly selected pupil from year 11 is a girl who stays on in the sixth form. What will that be?
G given 6.
6 given G.
6 given G, but they've already told us. So it can't quite be that. It's got 6 in there, it's got a G in there. Yep.
Is it 6 union G?
6 union G was...
I mean intersection.
Yes, intersection, that's right. The intersection is both things happening at once. So it's a girl, and that girl has also got to be in the sixth form. Now the word "and" isn't actually in there, but it's a girl, you can think of it, who stays on in the sixth form. So the "and" is that intersection, so it's that symbol there. So if you've got this one here, can we see anything else here that may be able to help us work this out? Before, when we've had conditional probability formulae, what have we done with those formulae to help us?
Venn diagram.
Sorry?
Venn diagram? No.
Not yet, just maybe from the formula.
6 given G equals 6
Okay, so we're going to sort of unpack that one. You've got the probability of 6 given G equals, okay, go on, what were you saying?
The probability of 6 intersect G over the probability of G.
Yeah, that's right, okay. Any conditional probability that you're given in the question, I would rewrite, first of all, the formula. It's always 2 letters or 2 things, intersection on the top, and the one after the vertical bar on the bottom. So, this one here, 6 given G, we know. This one here is actually what we want to find out. So we know the probability of G?
Yes, 0.45.
Yeah, it must be 0.45. If boys is 55%, that one must be 45%. So if I rewrite that, it's the probability of 6 given G, which I know is 0.75. Then over here it's the probability of 6 and G, which is what I'm trying to find out, over 0.45. So what calculation do I need to do now then to find the 6 and G, the missing bit? Lucy, what calculation do I need to do now?
0.45 times 0.75.
Yeah, that's right. Bring that up here and multiply. 0.45 times by 0.75 will give us what we want. And if you do that, you should get 0.3375. You Hayley mentioned a Venn diagram earlier. You can do a Venn diagram for this if you want to. Are boys and girls going to overlap?
No.
Are staying on in the sixth form and not staying on in the sixth form going to overlap? No, yeah, you either do or you don't. So rather than a traditional Venn diagram with the overlapping circles and things, I would split it up into sixth form and not sixth form, and boys and girls. And you can just sort of stick the numbers in from here, so you should know what you have. So we knew at the top boys were 55%, girls were 45%. What have we got so far? We've now got, we've just weighed out sixth form, stay in the sixth form, and a girl is 0.3375. So that's one in here. Sixth form and a girl is 0.3375. So what other box can I fill in now fairly easily? Yeah?
Girl and not 16.
Yeah, this one down here. How am I going to work this one out?
1 minus.
Careful, not 1 minus the one above.
0.45.
Yeah, we know that there's 0.45 in here altogether. So yeah, it's 0.45. Take away the number that we've got above, which we've just worked out. And if you do that, you get 0.1125. So we've worked that out. Okay? Right, is there anything else we can work out? Can we work out top left, for example? Yep. It will be 0.8. The 0.8 figure is, given they're a boy, the probability they stay in the sixth form is 0.8.
So you have to do the same equation.
Sort of. We know that if they're a boy, 0.8 of them are in here. So given that a boy is 55%, if I times that by the 0.8, I will get the number that's in there. It's 80% of those boys. So if I do the boys' number times by the 80%, that's 0.44. I get that one in there. Then the final one down here, how can I work out the final one? Yeah, take that away from the 0.55. I know there's 0.55 in this column altogether. So if I take away the top one, I'm going to be left with the bottom one, which is 0.11. So again, you can do some of these things using the formulae, some of these things by doing the drawing. So what was part B asking us to do? Part B, find the probability that a randomly chosen Year 11 pupil will not stay on in the sixth form. A randomly chosen Year 11 pupil will not stay on in the sixth form. How can I write that down, first of all, in the notation? What will go inside the bracket?
6 with
6 with?
Is it comma? I don't know.
Yeah, well, that little dash up there. Yeah, that's right. Okay, the apostrophe. Some books call it prime, 6 prime, or the complementary event. Yeah, that's right. Okay, so using what I've got, how can I work out what that probability there is going to be?
Add the 2 bottom ones
Yeah,
together.
add the 2 bottom ones together. This is not staying on in the sixth form, so that's just these 2 here added together, which is 0.2225. And part C is find the probability a randomly selected sixth form pupil is a girl. A randomly selected sixth form pupil is a girl. Can anybody tell me what the notation will be for that C?
Probability of the given that 6.
So, find the probability a randomly selected sixth form girl, so we've got given there a sixth form student, is a girl. Yeah, that's correct. Okay. So, this is one of those given formulae again. How can you rewrite that using the formula that we've had before? We used it earlier up today, we used it up here. How can I convert this into that fractional formula? What goes on the top, what goes on the bottom? Alice, what goes on the top?
B6 union G.
Have a look at that one up there. Was it a union?
Oh no, intersect.
Yeah, it's an intersection. It's an intersection of those things. It doesn't matter which way down you write it, the G and the 6 first, doesn't matter because it's both of them. And what goes on the bottom?
Over P G.
Yeah, have a look back here. What was on the bottom was what was after the line.
Number 6.
Yeah, it's always the same. It's always what's after the line that goes on the bottom. Okay? So, these numbers now we should be able to lift out of this table over here. G and 6. G and 6. That's that one there. 0.3375. Probability 6 is these two here added together, which is 0.7775. So you add those two together. And then if you do that divide, I'll tell you the answer is 0.434. So anybody who has any questions or any queries about that example? Yeah.
With the G given 6, isn't that the same as the one above?
The one we did above was 6 given G. So this one here, when given we're looking at girls only, what's the probability there of sixth former? Whereas this one down here we said, given we're looking at all the sixth formers to start with, whether they're boys or girls, what's the probability it's a girl? So it is a different thing. We're looking at a different subgroup of the people.